Hi there and welcome to our last lesson in our C3 topic, all about chemical economics, and this is all about nanochemistry. So taking the work we did last time on graphite and diamond, we're extending that to Buckminster fullerene, which is the third allotrope of carbon, and how technology has allowed us to open that ball up and develop something called a nanotube, and we're going to look at some of the uses of those nanotubes. Anyway, I will see you at the end. I hope you enjoy.
Okay, so here are our objectives for this lesson on nanochemistry or nanotechnology. So by the end of this lesson you should know and understand how developments in nanochemistry have improved technology. So Buckminster fullerene, which was discovered in the early 1990s, is another allotrope of carbon. Now, the word nano means very, very small, and this is where we're dealing with atomic level atoms. So if we were to look at the structure of Buckminster fullerene, you can see that it is a combination of hexagons, like we saw with graphite, and also pentagons in a spherical shape. Now you can see as well that there are actually 60 atoms of carbon in this shape. Now the discovery of this shape enabled us to start to develop nanotechnology, which uses these Buckminster fullerene structures and helps to develop similar structures to help improve some technology, which we'll look at in a moment. Now, with the discovery of Buckminster fullerene, chemists were able to develop nanotubes. Now, this is where they join together lots of the Buckminster fullerene structures, and they're able to make this tube-like structure. So you can see here at each of the points is a carbon atom, and again they're joined in that hexagon structure there with strong covalent bonds. Now if we look at it straight on, you can see that it does have that tube-like structure. So we've got the strong covalent bonds, almost like a sheet of graphite rolled into a circle. Now nanotubes have several uses. Because of their strength, they're able to be used to reinforce tennis rackets. Because they're able to conduct electricity, they're able to be used in connectors and semiconductors in molecular computers. And because they have a very large surface area, they're able to be used as more efficient industrial catalysts. Now, the introduction of nanotubes has also developed the way that drugs can be administered to patients. Because of this spherical tube structure, they're able to deliver drugs to patients purely by trapping the drug inside. Now this is really useful for new HIV treatment, as it can disrupt the way that the virus actually works and stop the virus having any negative effects on the actual person. So how do catalysts work using nanotubes? Now the nanotube itself is not the catalyst. The catalyst can be attached to the nanotube. This will then therefore increase the surface area of the catalyst, meaning that you can have a quicker reaction. So in terms of industry, you can get more product produced.
Okay, so that concludes our lesson on nanochemistry or nanotechnology. Let's review what we've done. So we have looked at the Buckminster fullerene structure and how we can take the ball structure that we have and open it up to make a cylinder. So that removes the pentagons within the Buckminster fullerene structure, and we end up with hexagons in the tube, and that's almost like a sheet of graphite curled round to make a tube. And then we've got some other uses such as catalysts, reinforcement for tennis rackets, and components in modern electrical molecular computers because of their relative strength, their electrical conductivity properties, and because of the increased surface area that they will have. So that concludes our C3 topic on chemical economics. I hope you've enjoyed it, and I'll see you again in the next topic. Bye-bye.